So, if you think back to 1979, right, there were these two physicists who, well, they mounted a laser on this massive block of rotating marble in Colorado. And, they were fully expecting to just prove Einstein right.
Yeah, that was the whole point of the setup, really.
Exactly. I mean, they were running this test on the speed of light, and it was an experiment that was so unimaginably precise it could detect a shift smaller than the width of a single atom across an entire continent, which is just wild to think about.
So the scale of it is completely mind-boggling.
Right. And they actually did find something, but it wasn't the perfect uniform speed limit that, all the textbooks promised us. Instead, they found this tiny rhythmic stutter in the speed of light, like a ghost in the data, basically.
A ghost that, frankly, violated the core laws of standard physics.
Yeah, completely violated them. So the scientific community did what it often does with perfectly reproducible data that it just cannot explain. They buried it.
They absolutely did.
They just labeled it an unidentified systematic error and, moved on until now.
Right, because it is a classic case of theoretical inertia. I mean, when you have a paradigm as successful and as deeply entrenched as Einstein's relativity, there's this tremendous psychological and even institutional pressure to just ignore the cracks in the foundation.
Yeah, nobody wants to break the model that works.
Exactly. But those cracks, those tiny anomalies, they are almost always the fault lines where the next revolution in physics actually happens.
And that is exactly what we are exploring today on this deep dive. Because, we are looking at a highly detailed, honestly incredibly paradigm-shifting paper by George James Dukas.
It's a heavy read for sure.
Oh, it really is. It's titled Transdimensional Unified Field Theory and the Brillet Hall Experiment. And our mission for this depth dive with you today is to explore a pretty radical premise. I mean, what if that tiny bit of noise from 1979 wasn't a broken machine? What if it was actually the key to unlocking the true hidden structure of the universe?
It is a profound paper. Mainly because it takes aim at a fundamental assumption that most of us just accept without even thinking about it.
Right.
Like, we've all been taught that the vacuum of space is isotropic, which, simply means it is identical in all directions.
Right. So if you are floating out in deep space, there is no true up or down or left or right, at least as far as the laws of physics concern.
Exactly. The void doesn't have a grain to it.
Yeah, like you fire a laser and the light moves through that empty void in the exact same way no matter where you point it. That's the baseline assumption.
That is the assumption, yes. But Dukas's paper, well, it argues that space is not an empty, featureless void at all.
Which is a huge leap.
It's massive. He proposes that space is this highly structured, multidimensional lattice ether. It literally has an architecture. And he claims that this specific, completely ignored anomaly from that 1979 experiment is the empirical proof of that architecture.
Okay, let's unpack this. Because to really understand this lattice theory, I feel like we have to start by digging into that 1979 experiment itself.
We definitely do.
We need to understand exactly what Elaine Brillet and John L. Hall were doing in that lab in Colorado and, why their findings were so problematic in the first place.
Right. So to set the stage here, Brillet and Hall were performing a high-precision test of Lorentz invariance.
Okay, and for those of us who need a quick refresher, what exactly does that mean?
Well, without getting bogged down in the textbook definitions, the crucial thing to remember about Lorentz invariance is that it demands the speed of light in a vacuum be exactly the same for all observers, regardless of their orientation.
So no matter which way you are looking or moving, light speed is constant.
Precisely. It is the absolute bedrock of special relativity. I mean, if you find a direction where light travels even slightly faster or slower, the entire foundation of modern physics starts to crumble.
Which is why they built an experimental setup that sounds like it belongs in a science fiction movie.
It really does.
I mean, they didn't just set a laser pointer on a desk. They needed a level of isolation from the outside world that is, frankly, hard to wrap your head around.
Yeah, the engineering was incredible. They utilized a helium neon laser, and they stabilized its frequency using something called a Fabry-Perot cavity.
Now, I want to pause on that for a second because the Fabry-Perot cavity is kind of the heart of this whole mystery, right? It's not just a hollow tube.
No, not at all. Think of it as an incredibly precise optical echo chamber.
Okay.
It consists of two highly reflective mirrors facing each other, and they are spaced an exact known distance apart.
Right.
So when you shine a laser into it, the light bounces back and forth between those mirrors thousands of times.
Right.
And because light is a wave, as it bounces back and forth, it creates an interference pattern.
So the peaks and troughs of the light waves are overlapping each other, basically creating a very specific, highly stable optical rhythm inside the cavity.
Exactly. Now, the frequency of that rhythm is entirely dependent on the time it takes the light to complete a round trip between the mirrors.
Because the distance is fixed.
Right, the distance is fixed. So if the speed of light were to change, even by an infinitesimally small amount, the time it takes to cross the cavity changes.
Oh, I see.
And if the time changes, the interference pattern shifts, and the overall frequency of the laser either drops or spikes. It is just a brilliant way to turn a really abstract question about the speed of light into a highly measurable question about frequency.
But to measure something that precise, I mean, you can't have a truck driving by outside and rattling the mirrors, right? The vibration would ruin everything.
Which is exactly why they mounted this entire delicate optical assembly on a massive block of granite.
Like a literal
It's actually a giant tombstone, yeah, just to absorb any ambient acoustic or seismic vibrations from the earth or the building.
And then, and this is the part that just blows my mind, they put that massive stabilized stone block on a turntable.
Yes, a continuously rotating turntable. It completed one full revolution roughly every 10 seconds.
Oh.
And as the table spun, the Fabry-Perot cavity and the laser light bouncing inside it was systematically pointed in every possible horizontal direction.
North, east, south, west, and everywhere in between, just over and over again, every 10 seconds.
Exactly. And the precision they achieved with this spinning stone slab was 1 part in 10 to the 15th power.
1 part in 10 to the 15th, that's 1 part in a quadrillion.
It is.
Which is a number so small it kind of loses all meaning for a normal person. So let's ground it for you listening. If you were measuring the distance from New York to Los Angeles, right, a sensitivity of 1 part in 10 to the 15th means you could detect a change in that cross-country distance smaller than the diameter of a single atom.
It was an absolute triumph of experimental design. There was no denying that.
Right. And when they finally ran the machine and analyzed the primary data, they found exactly what the physics community wanted them to find, didn't they?
They did. There were no large, glaring variations in the speed of light as the table turned. Einstein's special relativity held up beautifully on the macro scale.
But physics isn't just about the primary data. It's about the residuals. You know, the stuff left over after you subtract the expected result.
The noise in the margin.
Exactly. And when Brillet and Hall dug into those tiny leftover fluctuations, they didn't find a flat line. They found a signal.
They did. They found a fractional frequency shift of roughly 1.5 times 10 to the negative 15th.
A shift of a fraction of a quadrillion.
Yeah.
Now, I can hear someone listening to this and saying, come on, 1 part in a quadrillion, that's just static. That's a thermal draft in the room or like a loose wire somewhere. It's nothing.
And that is exactly what many physicists said at the time. I mean, it's the easiest explanation.
Sure.
But here's the critical distinction. Random noise acts randomly.
Right.
If it were a thermal draft or a bumped table, the data would show erratic spikes. You would get a messy, unpredictable graph. But this signal was not messy. It had a highly specific mathematical signature.
And what was that signature?
It was a second harmonic of the table's rotation frequency.
A 2 omega signal, the paper calls it.
Yes, 2 omega, meaning that as the turntable completed one full 360-degree rotation, this tiny anomaly hit a peak exactly twice.
Okay, wait. So it went up, went down, went up again, and went down again, matching the rhythm of the rotation perfectly.
Perfectly. Physicists refer to this as the second order, or P2 anisotropy.
So it's not random at all. It is entirely linked to the physical orientation of the laser in space. The laser points one way, the speed of light shifts a tiny bit, it rotates 90 degrees, it shifts back, it rotates another 90 degrees, the shift returns.
Exactly. And they ran this experiment over and over, collecting massive amounts of data.
They ran countless integration cycles, right?
Countless.
Yeah.
And this tiny rhythmic wobble just refused to average away. It was a perfectly reproducible signal. No matter how much they tried to clean the data, it was there.
Which puts the scientific community in a terrible bind, because Einstein's theory firmly dictates that this signal should not exist at all.
Right. If Lorentz invariance is an absolute law of nature, the orientation of that laser shouldn't matter one bit.
The speed of light cannot have a rhythm based on direction.
It simply can't. So the community really had a choice here. They could rethink the foundational laws of physics based on a signal that is a fraction of a quadrillionth in scale.
Which is terrifying for a physicist.
Very terrifying. Or they could sweep it under the rug. And this raises an important question about the sociology of science. What do we do when perfectly reproducible data contradicts a beautiful, deeply established theory.
In this case, standard physics labeled the signal an unidentified systematic error. They basically just concluded that the equipment must have been flawed in some incredibly subtle, undetectable way that just, happened to mimic a real physical signal perfectly.
Yeah, it was a convenient way to dismiss it, and for decades that was the end of the story. The ghost in the machine was locked away in a filing cabinet.
Which finally brings us to the Dukas paper and transdimensional unified field theory, or TDUFT.
Yes, TDUFT.
Because Dukas looked at that old data and said, hey, the machine wasn't broken, the theory of the vacuum is broken.
Dukas argues that relativity's conception of space as this inert, empty manifold is fundamentally incorrect. In TDUFT, space is replaced by a geometric medium.
A geometric medium.
Right. It has real physical structure, which the paper refers to as the phi-psi lattice ether.
Okay, let's spend some time on this because moving from an empty void to a literal lattice ether is a massive philosophical leap. I mean, it changes everything.
It really does.
I think the best way to visualize the difference is to think about an ice rink. Relativity's version of space is like a perfectly smooth, freshly frozen ice rink. It has no grain, no texture, no features.
It's a flat expanse.
Right. If you slide a hockey puck across it, the ice doesn't care if the puck is moving north or east. The surface is perfectly passive.
A passive stage for the actors, the particles and forces to play on.
Yeah.
Yes, that's the standard model.
But TDUFT's version of space, this lattice ether, is not an ice rink at all. It is more like a densely woven three-dimensional tapestry, or like a crystalline grid. The space itself is made of threads, and those threads have specific properties, alignments, and physical characteristics.
That is an excellent visualization. But in TDUFT, this grid isn't just a simple 3D mesh like a net. It is organized into additive dimensional tiers.
Dimensional tiers.
Yes, and this is where the theory gets extraordinarily precise. It doesn't just say, generally, space has structure. It defines the exact mathematical nature of that structure, tier by tier.
Right, and when I was reading the breakdown of these dimensions, I had a moment of heavy skepticism, I'm not going to lie.
That's a normal reaction.
Because in popular physics, whenever we start talking about extra dimensions, we are almost always talking about string theory.
Yes, the classic 11 dimensions.
Exactly. And in string theory, those extra dimensions are curled up or, compactified. They are so infinitely small that they don't impact our macroscopic world. We can't see them or feel them. But Dukas isn't doing that, is he?
Not at all. And that is a vital distinction to make. In TDUFT, the geometry is additive and freely expressed. These dimensions aren't hiding in tiny loops.
No.
They are overlapping structural layers of the reality you are sitting in right now. The ether, at any given point in the universe, carries contributions from all of these dimensional tiers simultaneously.
So let's walk through this dimensional ladder because we really need to understand the architecture of this tapestry. The foundation starts with what the paper calls D2, the second dimension.
But not just flat, inert space. In this framework, D2 is the photon plane.
The photon plane. Okay, what does that mean?
It acts as the geometric base, the two-dimensional planar wave substrate for electromagnetism. It is essentially the canvas upon which light is initially drawn.
Okay, so the base layer is a plane, the 2D plane. Then you add the D3 tier, the third dimension.
Right. D3 represents the electric field tier. This is the transition where the geometry moves from a flat plane into a volumetric space.
It puffs it up into 3D.
Exactly. It gives depth to the electromagnetic interactions.
And then the theory skips up to D6. And this one really threw me. Because the paper defines the sixth dimension as the local magnetic field tier. And it says this tier encodes rotational structure into the vacuum.
Yes, the rotational tier.
Wait, I'm stuck on this idea of a dimension just being rotation. I mean, in normal physics, rotation is just an action, right? It's something an object does within a three-dimensional space, like a top spinning. How can TDUFT treat rotation as a structural dimension itself?
It requires a pretty significant shift in perspective. Instead of thinking of rotation as an event happening inside space, you have to think of the potential for rotation as a fundamental property of space itself.
I'm trying to picture that.
Imagine a fluid, like water. The ability of that fluid to form a vortex, a whirlpool, isn't just an action that happens to it.
Yeah.
The capacity for that vortex is a structural property of the fluid's density and viscosity.
Oh, I see.
In TDUFT, the D6 tier is the geometric property of the lattice that allows for curl, for spin, for magnetic fields to wrap around a current. The vacuum itself has a built-in rotational grain.
Okay, that actually makes a lot of sense. It's the innate capacity for a vortex, literally woven into the grid. It's a feature of the fabric.
Precisely.
And finally, there's the D10 tier.
D10 is the 10th dimension, which the theory designates as the vacuum magnetic tier.
How is that different from D6?
Well, if D6 is local, tight rotation, like a small eddy in a stream D10, provides the long-range inductive structure. It allows magnetic effects to propagate and connect over vast cosmic distances.
Okay, so if I am looking at empty space, right, I am actually looking at the D2 planar base, puffed up into a volume by D3, given the capacity for local spin by D6, and wired for long-range connection by D10.
That is the tapestry, yes.
But a tapestry needs a loom. I mean, it needs rules governing how these threads interlock and scale. And the paper introduces two main operators that run this whole system, phi and psi.
Yeah, phi and psi are the absolute geometric engines of this theory. Let's start with phi. Phi is the golden ratio, mathematically roughly 1.618.
And I have to admit, seeing the golden ratio at the center of a unified field theory raised a huge red flag for me at first.
Why is that?
Well, you usually hear about the golden ratio in like art history class or architecture, or people talking about the spiral of a nautilus shell or sunflower seeds. It almost feels a bit mystical. Like, why is a Da Vinci ratio driving fundamental physics?
It's a very common reaction, actually, but it's rooted in a misunderstanding of what the golden ratio actually represents mathematically.
Okay, clarify it for me.
In TDUFT, phi isn't an aesthetic choice. It is the fundamental velocity operator. The golden ratio is unique in mathematics because it is the only positive number that satisfies a specific self-referential algebraic recursion.
Which is?
Specifically, phi squared equals phi plus 1.
Okay, but what does that algebraic trick have to do with physical space? Why does the universe care about that equation?
It has everything to do with spatial scaling and efficiency. When energy propagates through this lattice, moving from the flat D2 plane into the volumetric D3 space, it has to scale up. It has to transition across dimensional boundaries.
Like climbing a staircase.
Exactly. And the mathematics of phi provide the most energetically efficient pathway for that recursion. It dictates how the geometric structures of the vacuum scale relative to one another with the least amount of resistance.
Oh, wow.
So it is not a mystical number at all. It is literally the fundamental scaling factor of the lattice's geometry.
So phi governs the spatial scaling, the velocity of the geometric expansion. And then we have psi.
Yes, psi is the time operator. If phi governs how the geometry expands and scales in space, psi governs temporal recursion and harmonic attenuation.
Harmonic attenuation. That sounds intense. What does that mean in plain English?
Think of it as a form of geometric friction or entropy. As a wave moves through this highly complex, multi-tiered lattice, it doesn't just glide effortlessly.
Right, because there's structure there. It's hitting the threads.
Exactly. The act of transitioning through these dimensions causes the energy to attenuate, to step down slightly, governed by the temporal rhythm of psi. It's a built-in resistance.
Okay, so we have a heavily structured grid made of specific dimensional tiers. We have it governed by the golden ratio for efficient spatial scaling, and we have the psi operator dictating the temporal entropy or friction.
That's the model.
This is a radically different universe than Einstein's empty void. And because the stage is so different, we have to completely rethink the actors on the stage. Specifically, we have to rethink light itself.
This is perhaps the most profound conceptual leap in the entire paper. In standard physics, we tend to treat light as an independent entity.
Right, a thing.
A photon is a particle, or an electromagnetic wave that gets emitted by a star and then shoots through the empty void of space like a bullet passing through thin air.
Yeah, the bullet and the air are two completely separate things.
But in TDUFT, light is not a bullet. Light is a wave mode of the ether itself. The light isn't traveling through the lattice, it is the lattice vibrating.
The analogy that really helped this click for me is a football stadium.
Oh, I like this one.
Imagine a packed stadium, right? And the crowd starts doing the wave. The people themselves, the ether in this case, are not running laps around the stadium. They aren't moving from their seats. They are simply standing up and sitting down in place.
Yes.
The light, the wave, is the pattern of excitation moving through the people. The medium stays put, but the event propagates across it. So light isn't a thing, it's an event.
That is an excellent way to visualize it. The composite field vector of electromagnetism is not an external field imposed on the vacuum. It is the ether lattice in a specific, measurable state of wave excitation.
And because light is just the vibration of this specific geometric structure, its speed cannot just be an arbitrary number,
But,
right?
and this is huge. In relativity, the speed of light, c is a postulate. Einstein essentially said, the speed of light is constant, let's build the math from there.
It just is. No one ever explains why it is 299,792,458 meters per second and not, some other random number. It's just a universal speed limit handed down from on high.
But TDUFT actually derives the speed of light from scratch. It builds the number.
That's crazy.
The theory argues that the speed of light is entirely determined by the geometry of the lattice.
Uh-huh.
The paper provides a formulation for this, which it refers to as the canonical light speed equation.
Let's break this equation down, because rather than just reading a long string of math, I really want to understand what these variables are actually doing spatially, like how they build reality.
Sure.
The equation builds the speed of light using the components we just talked about. It starts with a base of 2.
Now, that 2 is not just an integer. It represents the D2 operator. It signifies the photon plane, the absolute geometric foundation upon which the wave will propagate.
Okay, so you have your flat D2 canvas. That's your base of 2. Then the equation adds 2 terms, phi to the power of -1 and phi to the power of -2.
Right. These are the velocity recursion terms we mentioned earlier. As the wave excitation moves from the flat D2 plane and attempts to propagate through the volumetric D3 electric tier, it experiences a geometric translation.
It has to scale.
Yes. These 5 fractions represent the exact mathematical scaling of that transition. They're the spatial steps the wave must take to move through the lattice.
So we have the D2 base, we add the spatial stepping terms governed by the golden ratio, and then the equation subtracts a term. It subtracts something called A sub 0.
A sub 0 is the global harmonic attenuation constant. Remember the psi time operator we discussed?
Yeah.
Friction?
Yeah, the geometric entropy.
A sub 0 is the mathematical sum of that temporal entropy. It represents the infinite harmonic series of resistance as the wave propagates through the dimensional tiers. It is essentially a subtractive dimensional correction, and its value is incredibly precise, roughly 0.000208.
So let's put it all together visually. You take the flat D2 foundation, you add the energetic cost of scaling up into the higher dimensions using the golden ratio, and you subtract the inherent temporal friction of the lattice, the A sub 0.
That's the formula.
When you do that arithmetic, you get a very specific structural value. The paper calls this the effective denominator, D sub 0, and it comes out to roughly 3.616.
And that structural value anchors the entire theory of light propagation. When you process that underlying geometric ratio through the dimensional scale factor of 10 to the 8th, you derive the exact measured speed of light in a vacuum.
So what does this all mean for us? I mean, it fundamentally demystifies one of the greatest constants in physics. The speed of light isn't an arbitrary speed limit enforced by cosmic traffic cops.
No, it's not.
It is literally just the maximum rate at which this multidimensional phi-psi lattice is physically capable of transferring a vibration from one thread to the next. The speed of light is a material property of the tapestry itself.
And understanding that the speed of light is a physical property of a structured medium is the absolute key to solving our 1979 mystery.
Right, because we still have to figure out that Brillet Hall anomaly.
Exactly. Because if light is a vibration of a physical lattice, we have to ask a very practical question. How does a massive physical object interact with that lattice?
Right, because Brillet and Hall weren't floating in the empty intergalactic void when they did their test. Their turntable and their laser were sitting in a lab in Colorado attached to the Earth.
A very massive Earth.
So how does a planet interact with the tapestry?
Once again, we have to contrast this with standard physics. In general relativity, a massive object like a planet curves empty space-time, creating a gravity well. It's the classic bowling ball on a rubber sheet analogy. Everyone has seen that visualization.
Yeah, you drop a heavy ball on a trampoline and the fabric dips down. But if space isn't an empty rubber sheet, if it's a densely packed crystalline grid, mass can't just bend it in that same smooth way.
No, cannot. In TDUFT, mass does not curve an empty manifold. A massive body is a dense contraction node within the lattice.
A contraction node.
Yes. It is a region where the recursive geometry of the phi-psi ether is heavily compressed, drawn tightly inward upon itself.
The paper is very specific about this, actually labeling a planet as a psi to the 4th node. Now, earlier you said psi was the time operator, the engine of attenuation. Why does gravity require the 4th power of this time operator?
It is a beautiful mathematical alignment, honestly. The theory identifies this psi to the 4th operator as being exactly equal to the reciprocal of big G, Newton's universal gravitational constant.
Oh, wow.
Why the fourth power? Because it represents the physical depth of the dimensional folding. To create a mass, the lattice must undergo recursive contraction across multiple dimensional tiers. The fourth power represents 4 layers of temporal delay, a deep compression of the lattice's inherent harmonic rhythm. Gravity is simply the measure of how tightly the lattice is contracted at that specific node.
Okay, so Earth is this incredibly dense, tightly pulled knot in the fabric of space. It's pulled inward. But it's not a static knot, is it?
Not at all.
Earth is spinning. It rotates on its axis at over 1,000 miles an hour at the equator. How does that rapid rotation affect this multidimensional knot?
That rotation changes the geometry entirely. Because Earth is rotating, it doesn't just pull the lattice inward, it twists it. It creates a rotating ether knot.
Like twisting a piece of cloth.
Exactly. Now, recall the dimensional tiers we explored earlier. We talked about the D6 local magnetic tier, which encodes rotational structure, and the D10 vacuum magnetic tier, which governs long-range connection.
Right, the built-in capacities for local spin and long-range induction.
As the Earth spins, its massive side of the fourth contraction node literally grabs those anisotropic, meaning directional structures, and drags them around.
So if you were in deep space, millions of light years from any galaxy, the lattice is globally averaged out. It's relaxed. It's effectively isotropic. Its properties are the same in every direction.
Right, the A sub-zero friction is uniform.
But the moment you bring a planet into the mix and you spin that planet, the local D6 structure gets torqued. The isotropy is totally shattered. The tapestry develops a preferred direction based on the axis of the planet's rotation. The threads are actually twisted around the poles.
If we connect this to the bigger picture, this explains the mechanism of the anomaly. The attenuation term in our light speed equation, that A sub-zero friction term, is only perfectly uniform in deep, relaxed space.
Okay, I see where this is going.
But near the Earth, the twisting of the D6 and D10 tiers creates a tiny, orientation-dependent modulation of that friction. The ether actually vibrates slightly differently depending on how it's aligned with the Earth's rotational twist.
And the paper doesn't just suggest this qualitatively like a neat idea. It actually calculates the raw scale of this twist using a specific TDUFT formula called the operator product F.
Yes, F is critical.
I want to walk through how F is built because it shows how grounded this theory is in the physical reality of our planet. It's not just abstract math happening on a whiteboard.
The operator product F quantifies the total geometric distortion of the ether lattice at a specific point. To find it for a lab on Earth, you have to combine 3 distinct physical factors.
Okay, first, you start with the gravitational operator, that's psi to the 4th power, which basically sets the baseline for the contraction.
Correct. Second, you multiply that by the dimensionless gravitational depth of the planet. This is a ratio calculated using Newton's constant, the mass of the Earth, the radius of the Earth, and the speed of light. It tells you exactly how deeply the Earth's mass is pulling on the lattice right at the surface.
And third, you have to account for the spin. So you multiply by the rotational distortion, which is the angular velocity of the Earth, how fast it spins times its radius, divided by the speed of light, all squared.
So you are taking the fundamental lattice operator, combining it with the exact mass and radius of our specific planet, and twisting it by our exact rotational speed. When you execute that calculation, the math produces a value for F of approximately 2.4 times 10 to the negative 11th.
Wait, hold on. You're telling me that if you just plug in the mass and spin of the Earth into this lattice framework, the geometry automatically generates a raw distortion factor of 10 to the negative 11th?
Yes.
Because that is incredibly close to the tiny 10 to the negative 15th anomaly found in the 1979 experiment. I mean, that cannot be a coincidence.
It is a striking natural convergence. The raw, unsuppressed twisting of the lattice by the Earth puts us right in the neighborhood of the Brillet Hall data. But to get the exact answer, to bridge the gap between 10 to the negative 11th and 10 to the negative 15th, we have to look closely at the geometry of the experiment itself.
Right. We have to connect the giant rotating knot of the Earth to the tiny rotating marble slab in the Colorado lab.
Exactly. Because the laser isn't just sitting statically in the twisted ether, it is spinning inside it, sampling different directions every 10 seconds.
And this brings us to the crucial difference between transverse and longitudinal waves in TDUFT. In standard textbook physics, light traveling through a vacuum is strictly a transverse wave, right? It only oscillates perpendicular to the direction it is moving, like snapping a rope or a wave on a string.
Yes, that is the standard model. But TDUFT treats light as a wave mode of a physical structured lattice, and physical lattices can compress.
Like a slinky.
Exactly. A physical medium can support both transverse side-to-side vibrations and longitudinal back-and-forth compressions. In the TDUFT framework, the underlying ether wave state possesses both components simultaneously.
Okay.
The transverse vibrations correspond to that D6 local magnetic tier we discussed. The longitudinal compressions correspond to the D10 vacuum magnetic tier.
So the tapestry can shake side to side and it can push back and forth. Now imagine our Brillet Hall laser cavity spinning on its turntable. As it rotates, it is physically sweeping through this twisted space, sampling different directional projections of the ether.
When the axis of the laser cavity is aligned perfectly perpendicular to the Earth's rotation axis, it is primarily sampling the transverse D6 tier of the twisted lattice. When the cavity rotates to be parallel, it samples the longitudinal D10 tier.
So every time the table turns, the laser is continuously blending its interaction between the D6 thread and the D10 thread of the ether knot.
And there's a very specific mathematical way to describe the geometric mixing of two perpendicular tiers around an axis. It creates what physicists call a quadrupolar symmetry. Mathematically, it is represented by the second Legendre polynomial, which is written as P2 of cosine theta.
Okay, P2 of cosine theta. Whenever I hear polynomial, my eyes tend to gloss over, I admit. But when I look this up, a quadrupolar shape basically looks like a peanut or a dumbbell.
That's a good way to picture it.
It's a shape that bulges out in two opposite directions. So the twisting of the Earth's mass creates this invisible mathematical peanut shape in the local space of the lab. But how does that peanut shape actually force the laser to spit out the exact anomaly they measured?
What's fascinating here is how the mechanics of the rotation guarantee the result. Let's visualize the turntable again. It is rotating at its own steady angular frequency, sweeping through 360 degrees. Let's call that rotation rate lowercase omega. The angle of the laser relative to the Earth's axis, theta, is constantly changing.
Right, so it sweeps through the fat part of the peanut, then the skinny part, then the fat part again.
Exactly. When you plug that constantly rotating angle into the quadrupolar symmetry, the peanut shape, the geometry dictates that the laser cavity will experience maximum stretching and compressing of its optical path twice per full rotation.
Twice per spin.
Yes. Once when it sweeps through one lobe of the quadrupole, and again when it sweeps through the opposite lobe.
Which means the signal will peak twice per spin, which is exactly the 2 omega harmonic signal that Brillet and Hall found. It's not an accident at all. If space is a structural lattice, and the Earth's mass twists that lattice into a quadrupolar shape, a spinning laser must detect a signal that rises and falls twice per rotation. The geometry leaves absolutely no other option.
The signal ceases to be an anomaly entirely. It becomes a mandatory, predictable feature of the physical laws governing the lattice.
Okay, the geometric logic makes perfect sense. It's beautiful. But I want to push back on the math here just a bit because we still have a numerical gap. We said the raw Earth distortion F was roughly 10 to the negative 11th, but the actual measured data was roughly 10 to the negative 15th.
We are off by a factor of about 10,000.
Yeah, a factor of 10,000. How does the theory bridge that final magnitude gap?
The theory bridges it with a mixing coefficient, denoted by the Greek letter kappa. Kappa represents the physical coupling strength between the D6 transverse tier and the D10 longitudinal tier. It is essentially a measure of how strongly the rotational distortion of the higher dimensions actually translates down into the attenuation of the speed of light.
So Dukas takes the final experimental data, the 10 to the negative 15th amplitude, and back-solves the equation using the raw Earth distortion F. And he calculates that to make the equation balance, kappa must be roughly negative 3 times 10 to the negative 4th.
Yes, that's the math.
Now, I have to be the skeptic here, because whenever a physicist introduces a new coefficient to make their theory match the data perfectly, it feels a bit like a sleight of hand.
Like a fudge factor.
Exactly, like a fudge factor. They needed the number to shrink by 10,000, so they magically discovered a coefficient of 10 to the negative 4. How do we know kappa isn't just a mathematical band-aid?
It is a vital question to ask.
No.
If kappa were just an arbitrary number pulled out of thin air to make the math work, the theory would be incredibly weak. But Dukas proves that kappa is deeply intrinsically rooted in the harmonic structure of the lattice itself. It's not arbitrary. We have to go back to the dimensional tiers to see why.
Okay, take me back to the tiers.
The light wave, the base propagation, operates primarily on the D2 photon plane. But the rotational distortion we are talking about exists up on the D6 tier.
Right, the local magnetic tier, the vortex level.
In order for the physical distortion on the D6 tier to actually affect the light wave down on the D2 tier, The energy has to translate across those dimensional boundaries. It has to couple the dimensions together.
It has to step down the dimensional ladder.
Exactly. And the mathematical cost of stepping down that ladder is governed by the lattice's fundamental scaling factor,
Mm.
phi, the golden ratio. The theory dictates that coupling D6 back to D2 requires 4 specific recursion steps. The geometric cost scales exactly at phi to the -4th power.
The golden ratio to the -4th power. Okay, let's do the math on that. What is phi to the -4th?
Phi to the -4th is approximately 0.146. Now, if you take that recursive scaling cost and you multiply it by the global attenuation constant of the lattice, that A sub-zero friction term we discussed earlier, which is roughly 0.000008.
You get approximately 3 times 10 to the -4th. Oh, wow. Here's where it gets really interesting. Dukas didn't just invent a number to make his equation work. The exact value needed to bridge the gap between the Earth's raw distortion and the 1979 laser data is organically generated by the golden ratio harmonic ladder of his own theory.
It's embedded in the structure.
And the paper makes a huge point of showing that you cannot do this with standard physics. You can't take Planck's constant, or the fine structure constant, or the mass of an electron, and just magically combine them to produce this specific 10 to the -15th anomaly. None of the established numbers in physics fit the lock. Only the specific geometric recursion of the phi-psi lattice fits.
It is a remarkable convergence of abstract theoretical geometry and hard empirical observation. The mathematics of the theory predict a coupling strength that perfectly maps to the experimental reality. And this is what leads us to the final and perhaps most profound section of the paper. Because explaining the Brillet Hall anomaly isn't just a historical correction.
It's bigger than that.
It serves as the keystone that locks all of transdimensional unified field theory together.
This brings us to Appendix C of the source material. It introduces something called the master projection equation. I want to connect this to the rest of Dukas's work, because TDUFT isn't just a single paper about one old laser experiment. It is a massive, multi-volume attempt to rewrite all of physics.
Yes, the scope is immense. Dukas has authored separate texts detailing entirely different scales of the universe. For instance, there is a volume called Maximus V3, which is dedicated entirely to particle physics. It details how the lattice geometry condenses to form the masses of subatomic particles.
Showing incredibly small.
Right. And then there is another volume, Black Hole V4, which explores cosmology, detailing how a supermassive black hole is simply an extreme runaway contraction node within that same lattice.
But they all use the same foundational math, right? They all use the phi-psi dimensional operators.
They do. But prior to this paper, the theory faced a critical hurdle. The mathematics in Maximus and Black Hole V4 describe an infinite, continuous, recursive lattice. But experimental physics doesn't happen in an infinity. It happens in finite laboratories. They possess the math for the infinite tapestry, but they lacked a rigorous mathematical mechanism to extract a finite, measurable, directional quantity that could be tested on a workbench.
They couldn't zoom in from the cosmic tapestry to a specific thread in a lab in Colorado.
Precisely. That was the missing link. The derivation of the Brillet Hall anomaly provides the exact missing piece.
Yeah.
The equation that maps the Earth's quadrupolar distortion onto that spinning laser, that is the unified master projection equation.
Okay, I want to summarize this to make sure I am fully grasping the magnitude of what Dukas is claiming here, because it's huge. He is stating that the exact mathematical equations that govern how a microscopic subatomic particle gets its mass, and the exact equations that dictate how a gargantuan supermassive star collapses into a black hole, are the exact same mathematical equations that caused a helium neon laser bouncing between two mirrors on a spinning marble slab in 1979 to fluctuate by a fraction of a quadrillionth.
That is precisely what is being claimed.
And this new master projection equation is the mathematical bridge, proving that they're all just different scales of the exact same geometric phenomenon.
Yes. The derivation proves that TDUFT is not just a mathematical fantasy floating in the realm of pure abstraction. It demonstrates that the theory is an empirically testable physical law. By successfully calculating the exact amplitude and phase of the Brillet Hall signal from first principles, this paper argues that the anomaly was the first physically measured property of the dimensional lattice itself.
It is the first time the tapestry has been caught on camera, so to speak. We finally took a picture of the ether.
It transforms the entire framework from a structural hypothesis into an experimental reality. The mixing coefficient, kappa, ceases to be just a number. It becomes the first measured boundary condition of the lattice. It demonstrates unequivocally that optical anisotropy, the shifting speed of light, as well as gravitational collapse and particle mass, are all just different dimensional projections of the exact same Fesi geometric operators.
Which completely reframes the history of that 1979 experiment. I mean, Elaine Brillet and John L. Hall didn't fail. They didn't build a noisy, flawed machine.
Far from it.
They actually achieved something monumental. They built an instrument so unimaginably precise that they managed to successfully detect the multidimensional structure of the vacuum. They just didn't have the theoretical dictionary required to read the data they produced.
And that new dictionary requires a tremendous sacrifice from the physics community. It demands that we let go of the comforting, simplified idea of an empty, passive void. It forces us to accept a universe that is intricately structured, deeply interconnected, and constantly vibrating with dimensional recursion. It is a much more complex universe, but mathematically a far more unified one.
So, to wrap up our journey today, we started with a discarded bit of data, a tiny anomaly, a ghost in a machine from 40 years ago, buried because it was too inconvenient for the established models. And we've seen how George James Ducas's paper uses that exact microscopic fluctuation to force us to reconsider the entire nature of empty space, not as a blank canvas, not as an ice rink, but as a Fesi lattice ether. A profoundly complex tapestry woven from physical dimensional tiers, mathematically governed by the golden ratio and the temporal flow of entropy, and physically twisted into quadrupolar knots by the spinning mass of planets like our own Earth. I want to thank you, the listener, for coming on this dense, mind-expanding deep dive with us today. It is a massive amount of conceptual physics to process, fundamentally restructuring how you view the empty space right in front of you.
It is a theory that truly rewards careful thought. And, it's a reminder to keep an open mind regarding the possibilities of theoretical physics, especially when the data refuses to cooperate with our assumptions.
And I want to leave you with one final thought, something sparked by the very end of the source material. Dukas notes that because of the harmonic ladder we discussed, TDUFT predicts that there are even smaller, higher-order geometric corrections to the speed of light. Things like P4 and P6 anisotropies, which were far too microscopic for the 1979 equipment to catch. But imagine if we built a modern interferometer today, one that is magnitudes more sensitive than what Brillet and Hall had in Colorado. And imagine if we didn't put it on a marble slab, but we put it or indel around the Earth, flying directly through the varying densities of our planet's ether knot. Could we theoretically use that data to map the exact three-dimensional shape of Earth's invisible lattice distortion? And if we could do that, what would a map of the ether look like if we flew that same ultra-sensitive interferometer near the extreme runaway psi-to-the-4th contraction node of supermassive black hole? Suddenly, that empty void doesn't just look like it has a structure, it looks like a steamer.